This is pre-algebra lesson 9-4. Draw a diagram. Many jobs require complex situations. To ensure that time and money is not wasted, people will draw diagrams to discover any problems and see possible solutions before they become potential hazards. Drawing a diagram is an important problem-solving tool. For example, let's say we have the following problem. How many diagonals does a nonagon have? To solve this problem, we should be sure of two things. We need to know, number one, what is a nonagon? And number two, what is a diagonal? Well, a nonagon is a nine-sided figure. Nine-sided figure. And a diagonal is a segment that connects two non-consecutive vertices. A segment connecting two non-consecutive vertices. There we go. One strategy for solving this problem would be to draw a diagram and count the diagonals. Since it may be very, very difficult to count all the diagonals after they've been drawn in, you might want to organize your results as you draw them. Make sure you do not count the same diagonal twice, for example. CE is the same as EC. So let's take a look at a diagram. Here I have a nonagon, and I've drawn in some diagonals to it. Okay? I've just drawn in all the diagonals from A. Okay? So if we look at that, the diagonals from A, and I'm gonna organize these quite nicely because it will be easier if I organize them. All the diagonals from A are, I can't do AB, but I can do AC. So I have AC, then I have AD, AE, AF, AG, and AH. And AI is not a diagonal because it's a consecutive side. So those are all the diagonals I have from point from vertex A. And if we count them up, there's 6 of those. Let's look at all of the diagonals that we can have from B. And I don't even need to draw them in, but I'll draw them in for this time just so you can see. And I can't go from B to A, I can't go from B to C, but I can go from B to D. So B to D is one of them. I can go B to E. So B to E is another one. I can go B to F. B to F is another one. I can go B to G. B to G. I can go B to H. B to H. And I can go B to I. B to I. To count those up, we have 6. Let's do the diagonals from C. And these will be probably the last ones I draw in, and then from then on I will talk about them, but probably not draw them in. I can't go from C to B because I've already done that. I can't go from, it's just not a diagonal. I can't go from C to D because that's not a diagonal either. I can go C to E. I can go C to F. And I can go C to G. I can go C to H. I can go C to I. I can't go C to A because I already did A to C, and C to A is the same diagonals. This one I'll highlight it here. It's this one right here, which I already have. So I already have that diagonal, so I can't use that diagonal. So if we count up all the ones from C, we have 1, 2, 3, 4, 5. Oops, I don't want to use my lighter. Let's erase that. 5. If I go from D, all the different diagonals from point D. I can't go D to E, I can go D to F, I can go D to G, I can go D to H, I can go D to I. I can't go D to A because that's already been done because it was A to D. I can't go D to B because that was already done when I did B to D. Okay, so I basically have, from that particular diagonal, I have DE, DF, DG, and DH. So there's 4 of those. If I go to E, okay, if I look at E, I'm going to do E here. I'm going to go, I can't go E to F, I can go E to G, I can go E to H, I can go E to I. I already did E to A, I already did E to B, I already did E to C. So basically there's three of them. The three diagonals that I can draw from point E are E, G, E, H, and E, I. G, E, H, and E, I. So there are three of those. The diagonals from F. Now let's see here, I haven't used the color on here. I haven't used blue, let's use blue. If I go from F, I can't go F to E because that's a side. I can't go F to G, that's a side. I can go F to H, and I can go F to I. I can't go F to A because it's already there. Okay, I can't go F to B because I've already done that one. I can't go F to C or F to D or F to E. Okay, so all of the diagonals from F are going to be F to H and F to I. H and F to I. So there's two of those. How many diagonals can I draw from G? I can't because now I have them all. I've drawn all of the diagonals from all the other figures, so I've also drawn the ones from G, so there's none from G I can draw. Okay, there's none from H I can draw because HA we already did, HB we already did, HI and HG aren't sides, and there are none from I that I can draw. So if I add these up, I would get, let's see, 6 and 4 is 10, 5 and 8 is 10, 20, 27 diagonals, I believe. 5, 10, 6 diagonals, I think. Wait, from G. Oh, wait, from G. Oh, I did miss one. I missed the one from G. There is one from G I can draw. Silly me. I missed G. G can have one, it can go G to I. It's the only one it can have. Poor little G only gets one diagonal. G to I. So now if I add these up, I get 27. I think there was 27. I just know that from the geometry class. So there are 27 diagonals. Now, goodness gracious, I wouldn't want to always have to draw a diagram like this. So maybe there's another way we can look at this. Okay? This diagonal is helpful, and it worked. It took a while. But could you imagine now trying to find out how many diagonals we could draw from a 102-sided figure? That could take us a very long time. So we might want to look at a different approach to the same problem. Okay? A different approach to the same problem might be to start with figures with fewer sides and see if there's a pattern. Okay, so if I have a triangle, okay, a triangle has 3 sides. 3 sides. The number of diagonals, it has none. If I use a quadrilateral, it has 4 sides. Let's look at how many diagonals it has from all the vertices, because these were all the vertices. How many total diagonals? Well, I can draw a diagonal from here to here. I can't draw any other diagonals. That would be 1. Okay. A pentagon has 5 sides. 1, 2, 3, 4, 5. 5 sides. Let's draw the diagonals. I'll use it. I love it. It's a little easier. There's 1, there's 2, there's 3, there's 4. There's 5 diagonals there. So it has 5 diagonals. If I do a hexagon, I have to draw a bigger hexagon. So I will draw a hexagon. 1, 2, 3, 4, 5, 6 sides. If I draw in all the diagonals of my hexagon, let's see if I give it to you. So we have 1, 2, 3. That's all the ones from that one. 4, 5, 6. That's all the ones from that one. I already have 1. 7, 8, and 9. Looks like we have 9 diagonals for that one. So now let's take a look at this. As the number of sides increases by 1, let's take a look at the diagonals. Okay, this goes up by 1. This goes up by 1. Oops, I messed up. All the way back here. Let's go back up here. I missed a diagonal for you. I forgot that the diagonal over here. So there's 2 diagonals in a triangle. There's no diagonals. In a quadrilateral, there's 2. In a pentagon, there was what, 5, right? And and in the hexagon there's 9. That's better. Now let's take a look at this. From 0 to 2 goes up by 2, right? From 2 to 5 goes up by 3. From 5 to 9 goes up by 4. So if you look at this, they're going up by consecutive numbers, aren't they? Plus 2, plus 3, plus 4. Since it goes up by 2, plus 2, plus 3, plus 4, let's take a look at this. Let's see if we can continue this pattern. Okay, I'm just going to continue this pattern to check my results. So, if it had 6 sides, it had 9 diagonals. Okay, so 7 sides would go up by 5. So 9 plus 5 is 14. 7 sides would equal 14 diagonals. 8 sides would go up by 6. 14 plus 6 is 20. And 9 sides would go up by 7. So 20 plus 7 is 27. So yes, it does check, doesn't it? So that to me seems like it's a little easier to use than drawing all the diagonals and naming them. So how many diagonals does a dodecagon have? It has 12 sides. So think about this. 3 sides, 0 diagonals. 4 sides is 2 diagonals. 5 sides, okay, we're going to add in 2, and we're going to add 3, right? So this would be 5. 6 sides would be add 4. That's going to be 9. 7 sides, we're going to, we added 4 here. Now we're going to add 5, and then we're going to add 6, and then we're going to add 7, just to help you out. 9 plus 5 is 14. If it has 8 sides, we're going to add 6. 14 and 6 is 20. Now we're going to add 7. It's 9 sides. It's 27. Now we're going to add 8. 10 sides. 27 plus 8 is 35. Now we're going to add 9. So 11 sides is going to have 35 plus 9, which is 44. And then 12 sides, we're going to add 10. So 44 plus 10 is 54. So a dodecagon will have 54 sides, or 54 diagonals. It was a whole lot easier for me than drawing a 12-sided figure and counting all the diagonals, because that would get really, really old. So if you can find a pattern, that makes it helpful. And that pattern was only found in this case by drawing a diagram. The diagram helped us. And in this case, this diagram helped immensely up here, this table. In the previous page, the diagram of the diagonals helped, and then we looked at that to see if we could figure out a pattern to that. And that's drawing diagrams to help you solve problems.